In this video, we're going to talk about scatter plots. And to start off with that, we're going to look at some vocabulary words. There's a lot of vocabulary that goes with scatter plots. And it's some words that you've probably heard before, but there's also a couple new words. So we'll go through those and then we'll answer some questions and look at some practice questions associated with scatter plots. Okay. All right, so to start off with, what is a scatter plot? Well, all a scatter plot is a graph, but it has a bunch of ordered pairs on there, and they're not necessarily in a straight line. They might have some type of association or correlation where we could say, hey, all of these points appear to be going uphill or appear to be going downhill, or there may be no correlation or no association. So we'll get to those in just a minute. It says a graph of ordered pairs in the coordinate plane that represents the values of two variables. And right here, this is a word called bivariate. All bivariate means is two variables. So that's all it means. So we'll have a variable for the x terms and a variable for the y terms in our graphs. Okay. Next term is outlier. We talk about outliers in sixth grade. It's just a data value that kind of sticks out from the crowd a little bit. It's a data value that is much greater or much less than most of the other values in the data set. So for an outlier, it's pretty easy to notice when you're looking at a graph where there's a bunch of points and they all seem to be clustered around a certain section on the graph, but then there's just one point that's either a little bit more than all the other points or a little bit less, and it kind of stands out, and it's generally easy to identify. So a word that I just said was cluster, and that's not on my list here, but a cluster is what it sounds like. It's points that are tightly packed together at one area on the graph. Okay, moving on down. Association. Association is just the relationship between two variables. So we could have a positive association, which means when one variable increases, there is an increase in the second variable. Okay, so we're going to look at some sentences here in just a minute that give us two variables, and we'll decide, hey, if one of these goes up, will the other go up? Or if one goes down, will the other go down? Or if one goes up, is the other going down? And we'll kind of navigate those in just a minute. A negative association is when one variable decreases with an increase in the second variable. Okay, so we got increase for positive, and we have decrease and increase for negative. Okay, so it's similar to thinking about slope. All right, so if I think about rise over run, my increase, that would be like going up and right. Well, those are both positive movements on a coordinate plane, so that gives us a positive slope. Now, if you think about how we graphed, we said we can either go up and right, or we can go down and left, both to represent a positive slope or a positive association, or correlation is another word you might hear. Okay, so increase is positive, but also decrease would be positive, because that'd be like a negative over a negative, which gives us a positive. Now, for a negative association, this would be, think about rise over run, like going down and right. Okay, so if we go down and right, that's going to make our slope be negative, so it's going to give us a negative association. So we could decrease then increase, or we could increase then decrease. Okay, so that'd be like going up and left. Well, one of those is a positive movement, the other is a negative movement. So we have a positive over a negative, or a negative over a positive, which results in a negative slope or a negative association. Okay, the last two words here we know. Linear just means it's a straight line, and nonlinear means not a straight line. Okay, so those are vocabulary words. We're going to look at some sentences here that give us two variables, and we're going to decide what type of correlation or what type of association, those two words generally mean the same thing, that these 6 sentences have. Okay, so each sentence has two variables, and we're going to decide, hey, if one goes up, is the other going up? That'd be a positive correlation. If one goes up, is the other going down? That'd be a negative correlation. And if one goes up, it has no effect on the other. That would be no correlation. So let's take a look at these. Number 1 says the number of hours a person has driven and the number of miles driven. Well, I mean, let's think about it. If the number of hours goes up, right? So we're driving 2 hours and 3 hours and 4 hours. As those hours go up, are the number of miles we drive also going to go up? Well, the answer to that would be yes. So we would say this is a positive correlation. Okay, and that would work the other way. Right? If we don't drive very many hours, then our number of miles is not going to go up as much, right? So if we don't go on a drive, then we're not going to drive any miles. So we're going to be a positive correlation there, okay? Number 2 says the age of a car and the value of a car. Well, when we talk about automobiles, generally what happens is when you buy a car, drive it off the lot, it immediately depreciates. So it loses value as it gets older, okay? There's outliers out there where you have classic cars and things like that maybe keep their value or increase in value, but for the most part, generally, this would be a negative correlation, okay? Because if we think about it, as the age of the car, as that goes up or increases, my value is not going to increase, it's going to decrease. So we have one variable, age of the car, that's going up or increasing, and one variable, the value of the car, is decreasing. So that would result in a negative correlation. As one goes up, the other goes down. All right. Number 3, the number of siblings a student has and their grade in math class. Well, it probably doesn't matter how many siblings you have. That is not going to have any effect on your grade in math class. So we would say none. There is no correlation between number of siblings and performance at school, or in particular math class. All right, number 4, temperature and sales of mittens. Okay, well, if the temperature goes up, so it's getting hotter, what's going to happen to the sale of mittens or gloves? Is that going to go up or down? Well, when it gets hotter, people don't need to cover up their hands. So that is going to go down. So we have one variable that's increasing, one variable that's decreasing. So we would say this is a negative correlation. All right, it would work the other way too, right? So if temperature goes down, it gets colder, then the sales of the mittens is going to go up, right? So one's decreasing, the other is increasing. All right, temperature and the sale of ice cream. Well, in this case, generally speaking, when it gets warmer, right, the ice cream truck makes his way around because people want ice cream. Well, when it's January and December, I don't hear very many ice cream trucks driving around, because when it's cold or when temperature goes down, the sale of ice cream goes down, right? But when temperature goes up, the sale of ice cream goes up. So we would say this is a positive correlation. All right, the last one says the height of students and their test scores. Once again, I know some really tall people that do really well, really tall people that don't do very well. And that could work with students who aren't as tall. The height is not going to have any indication on their test score. So we would say there is no correlation here between the height of the students and their test scores, okay? All right, the last thing we're going to look at are some examples here. So if you notice here, this is page 247 in your book, so you can take a look at this as you're watching this video if you'd like. We'll look at number 3 and number 4. So number 3 says each scatter plot below can be described by one of the following types of association. We have positive linear, we have negative linear, nonlinear, and none. So if we look here at this first graph, we can tell that we have an association, right? All those points are together at a cluster. And to me, it looks like we're going downhill, right? So we would say this is negative and linear association, okay? Looking here, once again, we generally looks like we could put a line right there, okay? So, and it looks like it's going uphill, so we would call that positive linear. So that means the last two are either none or non-linear, okay? So right here, it looks like there is an association, okay? But it kind of forms a curve, right? So there is association, but it's not a linear association, so we would say non-linear. Then lastly here, there is no association at all. We got points that form a circle generally, so there's really no way we could put a line through there to represent a linear association, okay? Last thing we're going to look at, number 4, tells you to invent your own set of data. Now, if you follow the directions, it tells you that all x values must be between 0 and 20. It's because your x-axis only goes up to 20, and your y coordinates or y values have to be between 0 and 15 because that's how high your y-axis counts. Now on yours, it says the association between the variables should both be negative and linear, okay? So that you create your own scatter plot here, I made mine positive, okay? So this is me right here. I made a positive association. Yours is going to be negative. So mine's going uphill, That should give you an idea of the direction your variables or your scatter plot should go. And generally linear, so to be able to fit a line between our points, okay? All right, so the two variables that I chose were hours spent shooting in the gym each week. So we're talking about basketball here. So the more time, generally you would say the more time you spend working on a skill, the better you're gonna be, right? So that's gonna be the case here. So the hours spent shooting in the gym each week, and then on my y-axis it says points per game, okay? So we're gonna say, you know, if you spend X amount of time in the gym, that's gonna have an effect on how much you score in the game, okay? Now, right here it says 1 point should be an outlier, and label that point outlier. So hopefully right now you can see which of my points is the outlier, okay? And it would be this point right here. We would call that the outlier, right? Notice how it does not fit in with the rest of the data, okay? So if we look at my table, this represents, if I have a person who spends 0 hours, then they're averaging 2 points a game. All right, maybe they get in at the end, something like that. Maybe they just don't score a whole lot, but that might be because they're not spending very much time in the gym working out and trying to get better. All right, so now we see this person spent 3 hours, and this is hours each week, so not per day. 3 hours, 4 hours, 8, 11, 12, 15, 16, 17, and 19. So generally, if we notice here, as my X values increase, so from 0 to 3, I went from 2 to 5. I went from 3 to 4, I went from 5 to 13. Okay, but notice here, I went from 4 to 8, and 13 went down to 6. And so this point right here, 413, doesn't really follow my pattern here. So that's why it's the outlier. So this person, they only spend 4 hours in the gym each week, but they're averaging 13 points a game, all right? So they're not the norm. That doesn't happen to everybody. Most people that score a lot of points or do good is because they've worked really hard and put in the work, okay? So if you look, my data points are going uphill. I drew a line right there that I'm trying to fit the best possible in between all those points, okay? So that would be called the line of best fit, or the trend line, and we'll talk about that in a later video. But you just take your ruler and you're just trying to get probably the same amount of points above the line as below the line. So my line is an estimate, right? It looks like it could be a little lower. I might not have done a very good job of drawing it there, but we're just trying to get that line as a best estimate as possible to represent our data, okay? So that's scatter plots.